All right, guys. So thank you very much for coming. This is the inaugural Dublin Microservices meetup. And I'm guessing we have probably 90 people here, which is really, really cool. So I was in Berlin 1 or 2 weeks ago, and I was in Hamburg, and there were 2 microservices meetups with pretty much the same numbers of people as both. So you can see that there is a really, really interesting thing happening. People have been speaking about microservices, Fred, for example, for the last 2 years or so, maybe even more. But this stuff is really, really coming together. And part of what we want to do with this is form a community. So microservices is a really interesting new space, and lots of people are doing loads of different things. And this is a space and a community for everybody to get together and share experiences and kind of learn together. So we're going to have this meetup once a month. If you are working with microservices, feel free to contact me, because we are looking for real-world experiences and the learnings that people have had. I have to ask. Right? Anybody who's actually using microservices, please put your hand up. Let's see how we're doing. So that's about sort of 20%, which is really, really cool. And I guess I have to ask what you guys are using to write your microservices in. So who's writing microservices in Java, for example? And so that's about sort of slightly under 10%. And obviously, if you know us from that other meetup, Node.js. So that's actually about the same numbers. Anybody, just shout out, anybody writing microservices in any other languages? Go or anything like that?
Scala.
And Scala.
Clojure. And PHP.
And PHP, awesome. So you can see this is like a really wide open field. And this meetup is language agnostic and platform agnostic, so it doesn't matter what you're doing and what you're actually using. I think this community wants to hear about it. Okay, so what we're going to do is Adrian Trenaman of GILT Group is going to talk about how GILT uses microservices. They do some really, really awesome stuff. This is one I'm particularly looking forward to, because this is microservices in production, actually in the real world. And if you're thinking of using them and looking at how am I going to actually make all this stuff work in production, I think there's a whole bunch of interesting lessons here. After that, we're going to do a few questions, and then we're just going to do a few announcements and things like that. And then after that, hopefully the pizza will arrive. You can see the beer is already here. I can tell you that heaven and earth moved today to bring this beer to you. This is Metalman beer, so somewhat patriotically, it's a microbrewery in Watford, and we think they're really awesome, and we decided to bring them to Dublin so you can all experience it. If you're looking for an interesting little thing to do down the country one weekend, do their tour, it's really, really cool. So after beer and pizza, then I'll be doing a short talk on some of the stuff around microservices that we'll be doing in Nearform, and then Fred George, who is kind of a very, very large figure in the microservices movement, is going to talk about some of the challenges. I can see you shaking his head. He's the real reason we're here tonight. Okay, so without further ado, Adrian, please take the floor.
Nobody looked at my password. Gold stars. Awesome. Okay. So I've got a short amount of time, and anybody who knows me knows that I love talking and I can go on forever. So I'm going to try very carefully to keep it down to 20 minutes. I'm going to talk about how we ended up in microservices at GILT, right? Really, I'm actually quite a pragmatist when it comes to these things, and so there's a lot of things that we have not worked out. And actually, in a sense, today, what I'd love is to go away with kind of asking you guys, what are the approaches that you've taken to some of the challenges that we're hitting right now? But without further ado, so For those of you who may not know GILT, effectively we're a tech company masquerading as a fashion company, masquerading as a tech company. What we do is we buy luxury products, right, from really high-end fashion brands. We buy these typically at a discount. Sometimes they're stressed inventory, sometimes they're excess inventory, sometimes they're last season. But effectively we get them at a great deal, and that's the deal then that we pass on to our membership, right? These are our customers, okay? So a big part of what GILT does is we make the product look absolutely fabulous. So typically when we get the product, we shoot it ourselves. Currently we have 25 photo studios in operation in Kentucky, in Brooklyn, and soon New York. And so, effectively making the product look fabulous is just an enormous part of what we do. We're a real company, we have real stuff, we have a warehouse with robots, and effectively we receive real product which we ship out to customers. And effectively, I guess the reason I'm showing this to you is we have a very unique business model, right? And effectively the tech team of GILT is putting together all the software that runs this very, very unique business model. Get this inventory, get the inventory to our warehouses, get it up on our site and on our mobile apps every day, because effectively every day the new inventory goes live at noon. We have that inventory for maybe a short amount of time, 2 or 3 days, right? We let our members know we have it, and then they rush to the site, right? And this is our members, a herd of steaming bison. Effectively, the business model is engineered around the idea that there is scarcity, right? This is very highly coveted products, right? And if you look at our performance graphs on any given day, you've got this sort of, pre-noon kind of, yeah, we're doing well, and then you shoot straight up off a spike, right? All the activity happens at noon when people come to the site for the deals, okay? So, and that I think is what makes GILT, for me, super interesting beyond just an e-commerce site. It's dealing with the pulse load characteristics of noon. So, how did we start? How did we get there? So, I'm going to show you some kind of architectural meanderings. The first, in a sense, was, you're a startup and you put together an application, right? And you do it in Ruby, right? And you have a database. And you speed it up with Memcache, and you end up with something that looks like this, right? Now, it's all the boxes look the same size, right? But that's an illusion, because realistically, all of our code was in this Ruby on Rails little app, right? That got bigger and bigger and bigger and bigger and bigger. So a couple of things happen. Our customers are going through the code paths in that Ruby app, but also our own staff are going through the same code bases. All our business processes are all in that same app, right? All of our engineers are trying desperately to get code into this same monolithic app, right? And that's hard enough to work when you're all on one code base. But I think what was just really accentuated for us was in 2008 we got the brand Louboutin. I'm not into shoes, but apparently the ladies love Louboutin. And effectively, we just got completely inundated, right? Our site fell over. Effectively, Ruby could not handle the load that GILT was getting, right? No matter what way we tried to scale it. Now that's not an attack on Ruby. I love Ruby, but ultimately we needed to move on, right? So we ended up going to something like this over time. Now, as a business, we were exploding, right? So for scalability, we decided let's build a whole load of Java services, right? And these services were the ones down here, like obviously kind of like a product service that gives you information about products, a user service that gives us information about users. And effectively, we cache forward so much of our data into these services, and this performed very, very well. But if we look at effectively what was happening, one kind of thing that was not great was that the quality of these services in terms of the APIs was enormously ad hoc. A lot of the service endpoints were written using raw servlet APIs. So you never really had a clear idea of what were the parameters that this service really needed, and also what was the data that it returned back. Did you see this map of data? It's completely unstructured and absolutely loosely typed. Nonetheless, it worked, right? Performance-wise, we got some great performance out of these Java services at runtime, right? Sort of we had all these businesses at the same time. The GILT group had multiple websites on the go, right? So we ended up then breaking up into these kind of multiple lines. So GILT.com was served from that line on the left there. GILTcity.com. Our home business had a separate stack. GILTtaste.com. They all had this same pattern, which was effectively a front end built around Java server pages, right? Hitting a set of services, which were these fellows here, right? What the services did was really, in hindsight, not great. What they did was they produced models of pages. They produced the content that the applications normally would render, right? And so, in a sense, it works, but it actually was really failing us hard. So what was going wrong? Well, first, the bulk of the commits that we were making on any given week or month were all on this monolithic Java app called Swift, right? This was a huge bottleneck, right? You know, you're a team and you want to get your software out. Some other team has got a branch that's been merged into this monolithic code base, and effectively they're breaking something in production right now, so your branch is not going to get merged, right? And this was a tale of woe and a tale of massive unproductivity as well. So you're kind of just waiting for your code to get out. So that was very hard, okay? There were also some very strange things that were happening in this model. When we looked at, for example, one of our services which did the bulk of the content on GILT.com, it was doing some nasty things. It was secretly going to the database instead of going through the services here. Because it was taking data directly out of the database, it was kind of doing business logic and nice kind of bits and pieces that none of the other teams could actually use, right? And I remember the day actually, the first microservice was about 3 years ago, where they simply said, the only thing I want is for a given user to know what today's marketing message is, right? Is it 20% off or is it whatever, right? And it turned out all the logic for that was buried deep inside this thing here. And in order to get that tiny piece of information, I had to ask for the entire content for the homepage and do a JSON browse through it and find that one little piece of information that was required, right? Wrong. So we created this tiny service called SVC Marketing, the marketing service. And what it did was it gives you the marketing information for a given user, right? It was probably about 200, 300 lines of Java code. And at the time, I was chatting with our CTO, he was like, I'm not sure this feels right. This is a really tiny service and we're going to run it on a virtual machine for it. It feels like overkill, right? But nonetheless, we kind of proceeded. We said it feels right. I mean, like it's a small service. It is a microservice, if you will, but it actually feels right. So that was actually just the start of it. Breaking code out of there. One of the other things as well that really that I felt very strongly about. I know there's obviously lots of discussions about code reuse, right? Sometimes it's expensive to reuse code, right? However, what we were finding was the cost of not having good, solid code reuse across these business lines was absolutely killing us. So, he asked kind of some big questions, right? Like, how can we, as a software team, how can we really react to what the business needs, right? How can we figure out initiatives, right? Put teams around these initiatives, and then write code and get it to production really fast, okay? That's effectively what we wanted to do. So, we did a couple of things then that were counterintuitive, right? But largely cool, right? And largely we feel that at the end of the day, we've come to a very interesting place. Like I say though, there are some things that kind of hit us along the way. So legacy never goes away. There's always stuff that's out there. It's very rare to get to decommission something. What did happen that was interesting was the applications that were monolithic, the big Swift application, we actually broke that up, right? Now, we adopted an architecture called lots of small applications, right? LOSAP, right? And effectively, we actually went down to the page level. We said, we're going to have an application that serves the product detail page. We're going to have an application that serves search listings. We're going to have an application that serves our home page, right? What this allowed us to do is have lots of much smaller repositories that any team could commit code to, any team could deploy separately from all of the other teams, right? So there was no more trying to choreograph, 90 engineers all on the same code base, right? We broke it all down. I wouldn't necessarily do that this way today, right? But I have to say, at the time and where we are now, I actually do feel pretty good about it, okay? I might do it differently knowing now what I know now. Anyhow, the interesting thing there is in terms of the number of apps in the front end, I always felt that 7 plus or minus 2, the magic rule of 7 plus or minus 2 was a good number, because conceptually everybody can keep in their minds, right, these rough 7 areas of the user experience for our site. Okay. Now, the teams went absolutely crazy, though, in a great way. So actually, technology-wise, we used play. This is where we just said, screw the monoliths. When you want to build something new, to do something great, build your own service, right? And effectively, we split up into multiple teams working in parallel. Currently, we have 24 initiatives, strategic initiatives across different teams running in parallel in the same organization. And no team is held up by the work of any other team, right? And this is facilitated by the fact that we literally let people build the services they need to do the job that they want to do right now. Scala, our adoption of Scala was quite liberating at this point. This graph here shows the rate of services, the rate of the number of services changing over time, right? There's a point of inflection around January the 12th. January 2012. That was the point where we decided as an organization that we were no longer a Java house, that we were a Scala house, right? And as part of that kind of pivotal moment, the microservices explosion simply took off. So, what all the services do, I mean, at the end of the day, you're an e-commerce site, right? So, you got to wonder, how is it that we have all of those admin apps, 32 admin apps, for our internal tooling, and this many services, right? So we did a word cloud, right? Obviously, this is a list of all of our repos in Garrett and GitHub, and effectively just threw it into a word cloud. And there's some interesting things that kind of happen. You see kind of the kind of work that we work on. Recommendation, there's a lot of services around machine learning algorithms and recommendation systems. There's services around search. Email is one of the key ways that we bring members to our site every day. We tell them every day, here's what we have today for sale, right? There's a city business, so there's some city services there. But ultimately, there's tons of services, and every service has its place. Now, how big are our services, right? So this graph shows the lines of code per service, right? The x-axis is logarithmic, because without it being logarithmic, you couldn't get any pattern at all, right? What we see is that the median is that any given service contains 2 to the 11, 2 to the 12 lines of code, right? That's lines of code calculated using CLOC, right? It includes XML, Java, Scala, build artifacts, build information, etc. Okay? Feel pretty good about that, where we have a fair whack of services that are all less than 2,000 lines of code, all in, right? We have a non-trivial number of services that are less than around 500 lines of code. I think that's actually pretty good, right? And then, of course, we have some behemoths. We have some services over here that are absolutely just completely bloated, and that tends to be the older legacy stuff. Source files per service, right? Some interesting metrics here. Well, okay, how many files are in any given service? And again, we've moved to a pretty reasonable place, right? 2 to the 5, 2 to the 6 number of code files in any given service, okay? Again, that's actually quite nice, right? You get the idea that we can get into any given service, just parachute an engineer in there, and they can figure out what's going on in a pretty short amount of time. Okay? And that's, I think, one of the real benefits, right? You don't end up having these crazy services that nobody understands, because we're trying to get to a point where they're absolutely small, perfectly containable, and really, really easy to use. When we deploy, these are the instances per service, right? It turns out that most of our services are deployed over 3 nodes. This is standard kind of availability stuff, right? Sometimes we deploy on 2. By default, we will always deploy any given service on 3 nodes, just to make sure that you can have, rolling deployments, and that if you lose any node, you don't feel too bad about it. Okay? So, lots of goodness there. Now, Right now, the infrastructure for GILT is deployed over 2 data centers. One of them is in Phoenix and the other is in Virginia. One of the biggest things we're doing right now is we're moving the entire lot to Amazon. Okay? There's lots of motivations behind that, but one of them is when you've got teams which are encouraging to create services and deploy them in the real world, what happens is the teams need boxes to deploy them on, right? And that means you've got to have, you get up with a bottleneck around your infra team and your deployment team, okay? And so what we've tried to do is say, could we make it super simple for teams to provision their own software, sorry, their own hardware, so that they don't need to ask anybody for permission, they can just basically deploy what they need on the hardware they want. Every attempt that we've done to make provisioning of hardware super easy, right, has ended up in failure, right? And along in parallel, all of a sudden we discover, listen, Amazon is doing it all for us, right? And we really can't compete with that. So ultimately, we're moving the entire lot to the cloud, right? And that's actually been a very, very interesting thing. Our strategy, in terms of how we move everything, all of these services, all of this infrastructure, is the following. We've actually created this legacy VPC, right? This is like a lift and shift, right? We're taking all of the deployment architecture that we had in our data centers, and what we're doing is we're saying, let's just deploy those machines in Amazon, and let's move this stuff across. And that means then the existing stuff is just running in a different place. That actually works nice. What we're really encouraging, though, is that teams, or rather departments, which are kind of largish teams of about 20 engineers with a similar theme, these guys have their own Amazon accounts. And effectively, they can just deploy whatever they want, whenever they want. So on their own accounts, they can take over, they can use whatever database, whatever messaging queues, whatever deployment architectures, it's entirely up to them, right? So effectively, we're staying kind of rigid. We're bringing everything over into the cloud, but we're allowing these little pods below of I guess, just non-stop innovation. Do what you want, okay? It's interesting in terms then of, as we move to AWS, it's interesting that these are the sizes of machines that we're provisioning on this legacy VPC. So these are like our virtual data center. And actually, the bulk of them are micro, a significant amount of them are small. And as you can see there, we've got some mediums and larges for some very big boxes. So it's kind of nice. We're kind of really honing in on lots and lots of very, very small running elements. Okay? So, effectively that's the evolution of where we're going, right? Over time to this microservices architecture, and really effectively, getting lots of teams working in parallel to solve problems, right? That's effectively what we'll be trying to do, right? And there's a massive focus, kind of culturally as well, on autonomy. Let teams figure out what they want to do themselves. I think we have about 5 architectural standards or rules that we encourage people to adopt, but that's about it, right? We're very, very light touch. We really let the teams figure out what they want to do themselves. Okay, so what was great? What was good? Right, microservices. What we succeeded in doing was we decreased the dependencies between teams, right? Which meant that code can get faster to production, right? That's fantastic, okay? Because we have less dependencies between teams, we can run lots of initiatives in parallel, right? And that's also very, very good. So we don't have the bottlenecks that we used to have, right? The other thing as well is that the approach we've taken with a very, very loose set of architectural kind of principles is simply that you can choose whatever language you want, whatever build system you want. Effectively, it's up to you to decide, as an engineer, as a team, what framework you want to do. What we basically restricted simply is you must deploy using Docker, right? And you must be able to deploy to AWS. That's effectively it. But if you choose to write your service in Erlang or in whatever language, it's entirely up to you. Okay. Other things that we've seen then that are very, very good for us are we've seen graceful degradation of code, right? Last Friday, one team took out checkout for approximately 20 minutes. We fixed that very, very quickly. But another team then later took out login and registration on our site. Again, not a very clever thing, right? It was a really bad day. However, it turns out that basically the rest of the site ran just fine, right? So these components, the impact of them being broken was just in a very, very, very small area. So that was good. Okay. So what do I think is hard, right? And actually it's interesting, you know, like, yeah, I've been away for a while and I came back to GILT having actually worked in a team that was much, much smaller and didn't use microservices. So I'm kind of coming back into GILT from Tokyo and I'm going to go and, right, what are the things that we see that are still hard and that we haven't worked out, right? The number one problem is staging environments, right? We have we have so many services right now that running, creating a staging environment for multiple teams, right, is just enormously hard, right? Effectively, what happens is you think it's easy, you deploy it all, but then you realize that some services have longer startup times than others. There's startup dependencies, and effectively over time you find that when something breaks on any given staging environment, there's so many services there that the team who actually owns the staging environment doesn't know which service is broken, right? And this, we've thrown a lot of bodies, we've thrown a lot of blood, sweat, and tears at this, and we simply haven't been able to solve it, right? What we believe now is that testing in production is the way to go, right? And that I think is a kind of a very scary consequence, but something actually that we're really looking into. So we're actually looking into a lot of different techniques around this right now. So using obviously automated tests, dark canaries, canary releases. There's a number of things that you can do to make testing in production safe and enjoyable, right? And so basically, this is one of the key things we're looking into right now. I am really keen to hear how other people in massive microservice architectures are doing staging, because we are finding that hard. Okay? Ownership is really hard. Effectively, with all these services, with a very, very vibrant kind of economy for software engineers, people write services and then they go, right? And then you're left with this service and nobody wants to own it, right? And so this has actually been a problem for us, right? We're bringing that around by saying, well, these larger departments, these kind of teams of teams, we'll have ownership at the department level. What we decided not to do is have a site reliability engineering team at SRE in the way that Google does. We don't, just culturally we decided it's not right for us to throw software over the wall for somebody else to run and maintain. It's on the onus of a department. And of course, if they inherit a service that they don't like, they can rewrite it, right? It's up to them. It's up to them to get rid of it if they don't like it. So, deployment, mentioned this earlier on. We needed flexibility, and effectively what we're doing right now is we're building some really great deployment tooling over AWS and Docker to make it super easy and super flexible for us to get services deployed. Three more of these. Lightweight APIs. We very much settled on REST, and what we've started doing is being far better about how we define our services, right? And there's this classic thing. I used to work in a company called Iona Technologies. You separate the interface from the implementation. It's software engineering 101. And effectively, what we're doing now is we're designing our APIs in a programming language neutral way, using a framework that Mike has developed called API Doc. It started off as a documentation tool. You use this tool to document what your service does and the models of data that it returns. But now we do code generation with it as well. What's really nice there is the mantra is that when you generate a client or a server stub, right, it should use the minimal set of dependencies imaginable for that target platform, right? You do not want to be pulling in a whole rake of libraries that the developer never wanted, right? This is a really serious issue for us, right? We have 156 services out there right now, right? They're all using a commons library, a framework that we developed that's closely tied to a version of Scala, 2.9 I think it is. And effectively, the latest version, which requires everybody to upgrade, is Scala 2.10, right? And effectively now we've got to go through the laborious task of upgrading all of these servers, right? It's been a really hard lesson, I think, for me. I would never do it this way again. I think that when you have code generation technologies that can generate the simplest lightest client imaginable. I think that's really, really important. So the other thing then is one of the other challenges, which frightens the hell out of our auditors, right? So, you know, once a year you get these accountant types in and they come into your organization and they go, what? Any engineer just out of college can deploy to production? Are you insane? Doesn't anybody review their code before it goes? Isn't there like a single person who has to sign off on absolutely every change management request? And we're like, no, there isn't, right? And in that world, that really frightens the auditors. So what we've done is we've said, well, what we're going to do is we're going to provide really strong and intelligent alerting, so that if anybody did introduce something malicious into our production systems, we would all know about it instantly, right? So we're developing tooling which we'll open source very shortly called Cave. I think it's, I can't remember what it stands for. But it basically allows you to receive events from all of your services, build kind of really neat rules like, the orders that are shipped to the US in a given 5-minute period, if that number is equal to 0, then raise an alert, right? So basically it's going over a time series of events, looking for patterns or anomalies, detecting behavior that is wrong, right? And then raising an alert as it happens. And what's actually nice there is that the auditors are on board with this. If they can see a dashboard of all of these alerts and see that clearly that it's not possible for somebody to take down our business, then they feel good about that. Okay. But one last thing as well that we haven't actually cracked is this I/O explosion. Effectively, we call services, I call other services, I call other services. And we haven't been very structured or kind of authoritarian about how or when these services should call other services. This leads to redundancy sometimes. So I call a service that looks up the user data. It calls another service which also looks up the user data. It calls another service which again looks up the user data. So we're doing an excessive and redundant amount of work in some cases. The other thing as well is that we don't detect cycles in terms of service calls, right? So we arguably we could end up in a recursive loop on any given service call. It doesn't happen. But it is sort of something that we're more aware of now as there's so many services available. Sorry, that's it. So 6 challenges that I think are pretty important. Probably really worth considering for anybody who's thinking of going down the microservices route. Particularly, staging and ownership. These things were things that when we started, we didn't know. We didn't know the speed at which we were going to enter so many services. And we didn't know of the consequences that we were getting ourselves in for. So it was quite a learning curve for us. I think the way we feel about it is these problems are great problems to have. We feel we can solve them. And there are certainly better problems to have than the problems we had back in 2011, 2012, when we simply couldn't get software to production. So that's it. Thanks very much. If there's time for questions or whatever.
I think the last point you made in your problems is the solution to the first 2, which are the most important 2.
Interesting.
Okay, so the first thing to do is to have microservices that only go downwards.
Right.
Okay. So they only read
Gotcha.
or they write a certain part of your database. Right? But they don't have potentially cyclical dependencies on the services.
Got it.
In other words, so you have silos that only go down into particular parts of your data set.
Got it, yeah.
Okay. When you do that, then 1 and 2 become really, really easy. Right? And 1 in particular is the way you do it, and the last time I was here, I saw this is how they do it. I can't remember the context of who did it.
Mm.
What they did was they mocked up the database.
Got it, yeah.
Okay? And they had their production system that was currently running.
Yeah.
They had their new replacement upgrade for a microservice.
Got it.
Okay? And they load balanced the I/O
Sure.
out of both. Right?
Yeah.
And the new microservice that they were in testing with didn't actually return anything to the customer. Right? They mocked that. So the same request came from the customer.
Got it.
went to the production system, went
Yeah.
down to the real database, went back up and back to the customer. The customer didn't know this was
Yeah.
going on. The load balancer sent the same request
Yeah.
to the new upgrade
Got
of
it.
the same microservice. Okay? And the tooling system records both the return back that should have been sent back to the customer
Got it.
and what should have been read or written with the tables.
Yeah.
Right? And that's all you need to do.
Good.
So what you do is you put in your new system, load balance it out, send the same request down to your new microservice, record what the microservice sends back to the user,
Yeah.
compare that to what the production system sends back to the user,
Yeah.
and also compare back what the reads and writes are from the database.
Yeah.
And if you just run a regression test on those, and if they match up, then you can replace the microservice with the
Yeah.
instead of the old microservice.
I think we've discussed that as a technique, right?
Yeah.
We've used kind of a tap approach before, where we route data to multiple services.
Yeah.
So we've tried things like that, right? To your starting point, yeah, I think it's interesting. You are right. I mean, if we were able to condense our services into our departments in a better way, then these will be logically coherent services that don't actually call out on other fellows. That's a good way to think about it. I think what's interesting about GILT is effectively we're like an engineering anarchy, right? So effectively,
Sure, I understand, but the thing is that you can slice these things out.
yeah,
Right?
yeah,
And what you can do is you can put in, if you have a dependent service, like a service that is actually at a lower
Yeah.
level, that's serving your new microservice,
Yeah.
the one you're planning to put into production,
yeah,
you can basically copy and paste that guy
yeah,
and get him to mock it.
yeah, yeah,
So, like you can do that in a shallow tree.
yeah,
But the important thing is with the microservices, and Gus, came over here. I think he was in here when you introduced it to Ireland.
right,
The whole idea of the microservices is that they're very vertical.
right,
Okay, they have as few displaying out dependencies and interdependencies and potential graphs as possible.
yeah. I think you might be right.
And
Sad
the
the
thing is,
argument so
if you
far.
have real microservices, it's really cheap
Got it.
to put in a mock version of those.
Yeah,
And put in a tool version of those underneath your potential deployment architecture.
yeah,
And that's one of the key features of microservices. That you're trying to do this with a typical kind of Java application, right? You either have an entire other application, right, where you have 40 different arrows
Yeah.
going in every direction, and some of them in silos,
yeah,
or you have loads of little silos.
right.
Right, and the whole point of microservices is you get as much siloization as possible.
So I think, I think you're right. I think that where we're going in terms of the departmental model, where department-owned services and they're cohesive, effectively will bring us to that, right? I think though we didn't start with that in mind, and so we entered an explosion, which leads us to the dark side.
Sure. But like the thing is, you've already discovered that you can have duplication of functionality across
Yeah,
all these teams, right? So, like the whole move from going from having like 5 different big modules
right.
to having 40 or 50
Yeah,
different modules, there's loads of duplication
sure.
across those. But the thing is that you have teams who own all of this piece of code
Yeah,
for their set of modules.
Yeah.
Right? And all I'm saying is do even more of that,
yeah,
right? And get them to own the stuff down below as well.
yeah, yeah,
So that they own everything down, right down to the persistence layer.
yeah,
Right? And that's all you need to do. Right? You've already taken the big step is to go from having a whole load of people who don't know who else to ask about changing something, to having this team owns practically everything below us.
yes, yes,
Right? And I'm just saying, just give them everything.
yeah,
Right? Just give them all the way access, all the way down to initially a mock database until they've proven their system replaces an
yeah.
existing thing all the way from top to bottom.
Got it.
Now, you have to be kind of fascist about it from the top, but that solves the
Yeah.
second question, which is ownership.
Right.
Which basically, if that team owns everything all the way down to the bottom, and they break it, they own it.
So a non-technical question.
Yes.
Do you think that the culture inside GILT enabled you to move to microservices, or do you think that microservices has changed the culture of GILT?
I think it's. I think the culture of letting smart people effectively do what they want, right, has always been there, right, and that there's a sense of anarchy which is genuinely intentionally chosen, but it's highly decentralized.
Anarchy is a type of government.
Right, exactly, right. So in a sense, that has been explicit from there, right. I think effectively the original models that we tried in terms of getting software out, effectively they failed, right? And then I think all of a sudden, you can actually see from the rate at which the services started, it was like a release valve, right? So I think it's actually kind of been good. It sort of allowed the anarchy to flourish. So, sure.
So just to build on that question, our software, we're using microservices. Our software environment does not allow us to walk away from auditing and regulation. It's a medical, life-critical application, so it's just a massive entry to that marketplace.
Yeah.
Do you think that using microservices, if you can't have that kind of freewheeling culture, would work?
I think it's hard for me to say. I mean, the only organization that I've worked in which is a massive microservice architecture is at GILT, right? And there is a culture of absolute freedom there. I think it's hard. It's hard. I can imagine the audit requirements may be different for a medical system. Certainly as well, security requirements in other areas may be much, much stronger than ours. Like, for example, the largest, the bulk of our data that we send across our services has no personally identifiable information in it. We can send it practically in the clear if we want, right? I think that microservices in a highly secure, data-sensitive architecture where governance is required probably requires a very different take from the way we've done it.
Okay.
Yeah.
Thanks.
Right.
Sure.
How do you handle service discovery and configuration management with that many services?
So it's actually, I think I got mocked actually by a colleague at one point. So basically our service configuration is all made available via Zookeeper, right? And the smart clients, one of the things that was good about the smart clients is they initialize, they detect Zookeeper, they read their config, and effectively they're all auto-config. You don't even have to say what environment you're in; it just figures it all out for you, right? So Zookeeper has been very good there. Zookeeper, I think is being designed to do way more than just be a configuration management system, right? But nonetheless, that's what we use there. What was your second question?
They were related configuration management and service discovery.
Service discovery effectively then we've got some well-known DNS names, right? All service requests go through a load balancer, right? And it basically then load balances over the pool of services that are behind it. So.
One follow-up question.
Sure.
Logging across multiple services,
Yeah.
so you have a request come in that bounces through adjust the different services. Do you have some way of centralized logging where you can trace the request through all services?
We've obviously got all of our logs are currently quite distributed. We've used Splunk in the past, right, to allow us to trace what goes on throughout the entire service stack. The other tool that we actually use that's absolutely invaluable is New Relic, right? I mean, it is absolutely amazing in terms of monitoring services, seeing what's available, seeing what's up, and also then tracking errors and tracking flows through the system. So we've been, pretty impressed with New Relic.
Sure. Just how do you handle API versioning and related? How do you handle API contract evolution?
Yeah. So as you can see, we kind of evolved at a rate here, right? Originally, if you can remember the diagram, there was a bunch of those old Lucy type services, and the honest truth is there was no versioning, right? And we had a lot of outages. So effectively, people began then to realize, obviously, that when it came to these Lucy type services, which is really bad pattern, right? You could add something, but you could never take it away, right? And that was kind of the unwritten kind of rule, right? Add something, don't take something away, and test judiciously in the staging environment that you've got, right? The recent version of API doc takes into consideration, because it's a very explicit way of defining APIs, right? It takes into consideration versioning, and it also will allow you then to tell whether two versions are incompatible, right? Whether you have major point versions or minor point versions. So I think that that's effectively, if you were looking for a versioning solution, I would say look at API.me and you can see what's going on there.
Right. So you must have some governance then around, how many previous versions do you need to support and that sort of thing, or do you just use metrics to see, well, this version is no longer used by any service because it's tired?
So it's interesting. I mean, you kind of, I'd say if I look at what's happened, we have services that come into existence, they do their job, they do it well, and we don't evolve them over time, or they're small, they live with us for a while, and then if they're not needed anymore, we get rid of them. So we tend not to have a real problem of, oh my God, they're version 7 of this service. That hasn't happened to us. Yeah. Great.
Adrian, last.
Sure. Just a question.
Another question to put you on the spot. So it looks like most of your services are essentially they just offer a REST interface.
Yeah.
How do services discover each other? How do I know where to send my request?
Services discover each other. Right. This is really interesting. Yeah. So we do have like a service registry. We have a couple of ways, right? But actually, it's almost through folklore, right? Through folklore. There are some well-known services. Think of it like if I had to use a metaphor analogy. Think of it like a city. There are areas of the city that you know well, that everybody knows well, right? And then there's your own locale, right? Which is effectively the area that you're working on, you spend most of your time in, and you know the services that are available. And of course, if you need new services, you're creating new services, right? So actually, the current evolution of services and discovery is largely driven simply by folklore, right? That's a strong statement, but I'll say that, right? What I think is really interesting, though, is the move to Amazon has forced us to take stock. We have now got a real clear idea of what services are where, who owns them, right? And not only that, then, as we move to API doc, that becomes a registry for services. You can search, you can find a service that might be of interest, see the data model, and then you can use the services there. So that's, I think, where we're going. So, cool.
Okay, very cool.
Great.
Any last questions?
Yeah.
Last chance?
What kind of overhead does this introduce on the ops side when you're supporting 150 whatever services? I mean, like what happens when the next Heartbleed or Shell Shock comes out and you suddenly have to reboot 100 machines in a day? How does that affect your uptime or your user experience?
So that's interesting, actually. Like when we had Heartbleed, I mean, across the current set of machines that we have, right, it is a reasonably small subset of hardware boxes, right? Well, not reasonably, but a smaller amount than the other services we have. And effectively, I'm not sure of the deploy tooling. I don't know whether it's Puppet or Salt, but effectively, rolling any changes to those boxes was very quick. That hasn't been a problem for us. As we move to deploying into the cloud, the use of Docker gives us a whole lot more control over the environment that we run in. So I think we'll feel pretty good about that in terms of making it very swift and easy to get stuff out.
Sorry, you mentioned Puppet. Is it probably your deployment tool for services using Docker?
That's right. The guys now, I'm actually talking, I think the infra team is using Puppet, but they change every 6 months to the newest, sexiest thing, so I'm not sure what they're using latest.
You're deploying containers using Puppet at the moment?
So no, we deploy, so we provision our boxes, our original boxes using Puppet, right? And similar software.
Sure.
Right? Effectively now, what we're doing in terms of deployment is we're deploying our Docker images, right, into the cloud. We've built our own tooling, a set of tools called Ion Roller and Ion Cannon. The idea of ions being pushed out of the cannon, like software releases. And effectively, those are the tools that we're using then to take any given Docker image and get it, safely rolled out to production. Sure.
So I'm going to let Adrian off the hook.
Thank you.
So Adrian Trenaman, the GILT Group, ladies and gentlemen. Thanks very much.